Hello and welcome, geometry students. Hopefully by the time you watch this video or start this unit, it will be a great new year, January, new opportunities. So speaking of opportunities, we are starting 6.1 polygons today. So let's go ahead and get started. Polygon Angle-Sum Theorem. The sum of the measures of the interior angles of an n-gon. Okay, let's break some things down. One, polygon, that's a shape, a closed shape with three or more sides. So a polygon could look like something like this. It doesn't have to be a regular shape, a typical shape. I'm not using those synonymously. I'm using them in additively. So that's a polygon. And then angle sum, that means the sum of their angles. Let me erase that. So if any n-gon means it could have any number of sides. So the way we do that is we do n minus 2 times 180. Kind of a, interesting formula there. It has its derivations, and I'm not going to go into that today in this particular video, but I just wanted to give you the formula that the angle sum is this equation right here. Okay, so we're going to go ahead and apply it. What is the sum of the interior angle measures of a heptagon? Okay, so a heptagon is 7 sides, I believe. I actually gotta double check that. I'm pretty sure it's 7 sides. So what we have to do here is, what does n represent? So first thing we have to find is, what does n represent? So n is always the number of sides. So maybe I should write that in equals the number of sides. And actually I'm gonna move that up here. So n equals the number of sides. I didn't even talk about that, did I? Shame on me. Well, anyway, I'm going to give it a quick example so you know why it works. So if you put in n is 3 for a triangle, and you subtract 2, and then you multiply that by 180, you get 180 times 1, and that equals 180 degrees within a triangle. And that is true, heptagon. Now we're on to heptagon, and it's confirmed it has 7 sides. So a heptagon has 7 sides, so n is going to be equal to 7. So now we just type in 7 minus 2, and then we multiply that by 180. So if we do 7 minus 2, we get 5. So we multiply 5 times 180, and that equals 900. Equals angle sum. So 900 degrees equals our angle sum. All right. Tony Hawk, by the way, first person to do a 900 on a skateboard. Equilateral polygon. What does that mean, equilateral? So break this down into its 2 parts. We have equi, which means equal, and then we have lateral, which is talking about the sides. So equilateral polygon is simply a polygon that has equal sides. Okay, so all these sides need to be the same length. Notice how the angles don't necessarily need to be the same for equilateral polygon. See, these 2 angles are different from each other. So let's make them different colors. Those 2 angles are different, but that's not important for an equilateral. It just has to have the same side measurements. Now, what happens with this guy? What do you notice in this diagram? We don't know anything about the sides, but we notice that the angles are all the same as given by those little lines. So this is an not lateral, equiangular polygon, where all the sides, all the angles are the same measurement. Even though it doesn't really look like it, this isn't a fantastic drawing. What we need to do here is we're going to add, oops, I don't like that color. Let's make it orange. We're going to add these little lines here to indicate congruence. Okay, and then we're going to add some angles here too. Okay, and if we have all these sides congruent and all these angles congruent, that is a regular polygon. That means all angles and all sides are congruent. Okay, and I should have put this for these 2. Forgot to do that, so we can say all angles congruent for this guy, equiangular, and then equilateral, all sides congruent. So that's just a little bit more about the different types of polygons you're going to encounter. Corollary to the Polygon Angle-Sum Theorem. The measure of each interior angle of a regular n-gon is. Now, if we're talking about each, for example, let's break down 180 degrees. Okay, that's a triangle. Now, if it's a regular triangle, what does that mean? It means all the sides are equal. That means it's an equilateral triangle. Okay, regular and equilateral triangle are synonymous with each other, for the record. Now, what do we know about an equilateral triangle? We know that each measure of each angle is 60 degrees. How do you get that? Well, if you know the sum is 180, and you know that there's 3 angles in that 180 degrees, you just do 180 divided by the 3 angles. Now, the number of sides is also an indication of how many angles it's going to have. So you can just divide by the number of sides, and that will get you 60 degrees. Okay, now for any polygon, any n-gon as it's saying here, we already know the angle sum, okay, that was our top number, is going to be 180 times n minus 2. And if we want to divide by the number of sides to get the amount of angle, the degrees per angle, then we have to divide by the number of sides, n. And this is going to equal the let's say each regular polygons angle. And there's this formula for us now. Let's highlight it in gold, make it look important. There we go. Okay, so there is an important formula. And it's really just, it's the same thing as this, okay? Just you divide by the number of sides. So don't think like, oh, I need to memorize 2 formulas. No, just memorize 1 and then divide by the number of sides. It's not super complicated. Okay, so there's that. Now, example 2. And this one I would recommend using a calculator. Otherwise, you're just going to be essentially doing second grade work, just adding, subtracting. So it's asking for angle W. So all we need to do here is first calculate how much should there be in all the interior angles of this polygon. So we know that n minus 2 times 180 is going to tell us that information. So we need to find out what n is. How many n's do we have? We have 1, 2, 3, 4, 5. So we're going to have 5 minus 2 times 180. That's 3 times 180. That should give us what, 520? 540, close. So 540. So I know the sum should be 540. Okay? So I know that, let me write this out as an equation. Angle N plus angle O plus angle W plus angle Y plus angle S. Eventually you're not going to have to do this. I'm just showing you where it comes from. Equals 540. Now, we know a lot of these measurements. We know that N is 90. We know 110 is O. We don't know W. Okay, so we're going to leave him alone. W, we don't know. But we know this is 150, and then this is 120. And that's going to equal our big buddy 540 interior angles, the sum. Okay, I don't know why I put angles for some of these and others not. Whatever. Now, what you do here, from here, you're just going to add up these numbers. So we have 90 plus 110 is 200. 200 plus 150 is 350. 350 plus 120 is 470. So all this adds up to 470 plus W, angle W, equals 540. So now we just need to subtract both sides by 470. And we get angle W equals 70 degrees. I should probably just double check that. I can just hear people screaming through the camera, through the screen, that I messed up something and I would hate to get roasted for that. 470. Okay, yeah, I got it right. 70 degrees. So this equals 70 degrees. All right, Polygon Exterior Angle-Sum Theorem. This one to me is the coolest, and I'll give you kind of like a quick derivation of where it comes from. So it's talking about what is the measurement if you have exterior angles, so you extend the sides. Okay, so notice how we extended each side here. Okay, so this side got extended, this side got extended, and it creates these exterior angles. So that is an exterior angle with the extended side. You don't have to write this down. It's just for you to know, extended side. Okay? So if this shape, okay, this is a pentagon, okay, and I extended the sides. But what if I added more sides, okay? What if I added, like, lots of sides? So you can see here I'm adding more sides here, okay? And you can see it's starting to look like a different shape. So as I add even more sides, okay, so I'm going to add even more sides. I'm going to add a ton of sides here, and I'm going to extend these lines, okay? I'm creating a shape with lots of sides. I think I'm like 20 or something, okay? You can see it starts to take shape. And as you can start to see, it's going to start looking like it adds up to a certain number. Notice how it's starting to look like a circle. Well, in a circle, there's 360 degrees. So it turns out that no matter what the shape is, the exterior angles always add up to 360 degrees. Okay, I think this one's the coolest because every shape, even triangles, add up to 360 degrees. So let me just show you real quick. Okay, I already messed it up. There we go, something like this. Okay, so let's say this is an equilateral and this is 60, this is 60, this is 60. That makes these angles supplementary, these exterior angles. So that's going to be what? 120, 120, and 120. What's 120 times 3? Or 120 plus 120 plus 120? 360. So even with a triangle, every shape, the exterior angles are always going to add up to 360. So that's all there is for section 6.1. Hope you guys are having a great start to the new year. Look forward to seeing you in 6.2, so stay tuned. Thanks for watching.